Hi everyone, I'm Zhen from the University of Toronto. I'm going to present our paper, Armstrong, an empirical examination of pointing at non-dominant arm anchor US in virtual reality. First, we thank Toby Grossman and Michelle Annette for providing thoughtful feedback, and Dan Kirk for recording voiceovers for our video figures. While many interactions are common in VR applications, in the painting task, a stylus manipulated by the dominant hand often operates on a collection of controls anchored to a non-dominant hand. These apps utilize the space around our hands, and this is not surprising for psychologists, since they have found that proprioception enables us to sense the position and movement of our limbs through our sensory neurons, and presents our hand prioritize the space near the hand. Many applications have been treating the space around our hands as a reliable storage space, and we may take it for granted. But the form factor for smartwatch still suffers from limited utility, and simple extensions like these may not work, because they didn't take the special locations into account. For example, most people wear their watches on the wrist rather than on the elbow. These observations motivated our work, and we asked ourselves what areas around the user's arm can be most quickly and accurately targeted, and what is the performance-optimized layout of 3D UI controls around the arm. As a result, we conducted a user study to further investigate where and how to place UI controls around the arm. During the study, participants performed a series of pointing tasks in VR. A start button was displayed on the right side of their body, and it could only be pressed when they were in a start posture, determined by the virtual footprint on the ground and a green bounding box. The participants were instructed to select the target as quickly and accurately as possible. More engineering details are available in our paper. All possible target locations were distributed on a virtual conical frustum grid centered at their left arm. 3 independent variables were studied: longitude, latitude, and height. 2 awareness schemes were also included. In the knowing scheme, the participant would need to first identify the target before performing her selection, and in the knowing scheme, the target location was visible prior to the trial start. We use this condition to simulate users who have different levels of experience using a particular app. We adopt throughput as an index of performance based on the actual starting distance, size of target, and movement time. Detailed stat analysis and full results from our interviews could be found in our paper. Here, just to share a selected list of results and some discussions about them. In terms of longitude, targets on the medial side of the arm had higher throughput than those on the lateral side of the arm. Throughput decreased as targets move up the arm along the latitude axis from the wrist, forearm, and elbow. Throughput also decreased as targets move away from the skin along the height axis from close to medium and far. As a result, when throughput is of priority, the UI controls should be placed on the medial side of the arm, around the wrist, and close to the skin. Alternatively, if UI controls are expected to be used infrequently or avoiding accidental activation is critical, they could be deliberately placed in the low throughput areas, such as the lateral side of the arm, around the elbow, and far away from the skin. We can also use the throughput heat map results as a reference to get the highest overall throughput. For example, if we wish to place 5 UI controls around our arm, we can select the 5 cells from the heat map with the highest throughput value. Furthermore, if more controls need to be added, the heat map suggests a number of possible axes along which to position controls, while maintaining a high overall throughput. We also implemented the Unity plugin for these guidelines to apply our model automatically. The designer can set up multiple preferences and either preview the optimized layout in the editor mode, or choose to tune the parameters and navigate the planes in the play mode. Some interesting future projects could be built on this work. First, future work could increase the number of levels of each variable to ensure that more continuous data can be obtained and used to interpret between levels. Our plugin adopted a simple objective function to maximize the sum of throughput to achieve the best performance. Other parameters might be introduced to improve the algorithm, such as the density factor and usage frequency of different UI controls. Based on the throughput, we could also dynamically reset the targets to enable a smooth and consistent user experience over the entire space. Thanks for listening. For more details, please refer to our paper and video.